this is Ross. I am here today to talk to you about the last two sections that we didn't get to finish up on Monday, which are 1.5. We didn't get to finish a little section on that, as well as 1.7. So let's go ahead and get started. The one part that we didn't get to finish up in 1.5 that I wanted to go over with you is we didn't get to talk about what vertical angles are. So I don't have it up on my screen, but we did talk about in our notes what complementary and supplementary angles are. Complementary angles add up to 90 degrees, and supplementary angles add up to 180 degrees. And so one other terminology that we want to talk about is vertical angles. So you can see right in the middle of my screen here, vertical angles. The definition is a pair of angles whose sides form opposite rays. So if you remember what opposite rays are, it's when the rays are going out directly opposite from each other. So it forms an angle of 180 degrees, right? So B and D are opposite rays in this picture, and A and C are opposite rays. So we actually have four angles going on here. And the 1, 2, 3, and 4, you can see them labeled. The opposite of A is C, the opposite of B and D, so that makes angle 1 and angle 3 vertical angles. And that also makes 2 and 4 vertical angles. Now, vertical angles are actually really useful because, and even though it doesn't say it right on here, vertical angles are equal. So as long as you have opposite rays, they form basically a line, the ray forms a line, then the vertical angles are equal to each other, or another word would be congruent. So that's actually really helpful to us because if we have a set of vertical rays, like example number 1 here, we're actually able to use that, or vertical angles, we're actually able to use that to figure out other angles within our diagram. So example 1 says the measure of angle 2 is 52 degrees. Oops, sorry. Get my pen on here. Okay, so the measure of angle 2 is 52 degrees. Now, if you look at angle 2 and you say, is there another pair to angle 2 that it's a vertical angle? So does it have an opposite ray? So what I see here is that 4 would also form a vertical angle, so we would get the same measure of the angle. Okay, so 2 and 4 have the same measurement. Then we have to figure out what 1 and 3 are. And we can figure that out by looking at our angle here. So I'm just going to draw a line through this line here so we can see a little better. So what we have is we have 52 degrees for angle 2, and then we need to figure out what angle 3 is, right? Well, 2 and 3 are supplementary angles because they form this line, right? And supplementary angles add up to 180 degrees. So 52 plus what equals 180 degrees? Just happen to have that. It's 128 degrees. 128 degrees plus 52 degrees is 180 degrees. So then that leaves us to find what the measure of angle 1 is. But angle 1 is a vertical angle with angle 3. So we know that that is 128 degrees as well. We can double check by adding that to 52, which we know is 180. So that's a useful tool when we have vertical angles to be able to solve. Now, example 2 is a very similar example, except they've put some algebra in there for us to figure out. So first up, we need to figure out what our supplementary or our vertical angles are, and also to see if we have any supplements. So it looks like MRN, this angle here, I don't want to draw through too much, and PRQ form a vertical angle pair. And it also looks like NRP and MRQ form a pair. I'll put that way out there so we don't lose our wording there. The other thing that I notice is that we have these vertical angles. We also have supplementary angles, right? So looking at a different way, this is a line, and it looks like this forms 180 degrees. So those are supplements to each other as well. So we kind of need to look at all of what we have here. All of our measurements are either in X or Y. So I think that actually the easier thing would be to solve for X or Y instead of to have mixed equations. So I'm going to use my rule about supplementary angles, and I know that two supplementary angles add together to be 180. So that means that I marked over it, MRN, angle MRN, plus angle NRP equal 180 degrees. Okay, and we know that MRN is 6x minus 6, and NRP is 6x plus 6, and those angles added together equal 180 degrees, right? So if we do some math here, 6x plus 6x is 12x. Negative 6 plus positive 6, just 0, equals 180. And we get that x equals 15. So then we can plug that back in. 6 times 15 minus 6 gives me 84 degrees, right? And 6 times 15 plus 6 is 96 degrees. Now, to find the other angles, we could solve for y, just like we solved for x, or we could use our rules about vertical angles, right? So this angle and this angle are vertical angles, so we know that this is going to be 84 degrees as well. And then our vertical angle this way is also going to be 96 degrees. Okay, so that's how we can use supplementary angles, vertical angles, and then there are some problems with complementary angles to find values. All right, next we're going to switch up a little bit, so give me just a second to switch screens. And we are going to switch over to 1.7. Notice that we're going to skip 1.6, so you get to skip over that. You pull this into Paint. Okay, so 1.7 is finding the perimeter, circumference, and the area. And these are all things that you've probably been doing for a long time, but it's just going to be a review of what we know. So what we're going to talk about first is some common formulas for perimeter and area, and also circumference. So remember, circumference is like the perimeter, but it's what we call the outside of a circle. All right, so let's talk about the square, triangle, and rectangle. I'm going to go through these pretty quickly. The perimeter of a square that has a side length, a side that is length S is 4 times S, right? It's basically the side plus the side plus the side plus the side, or 4 times the side. The area is the side S times the side S, or you could write it as S squared. Okay, I think that's all pretty straightforward. Then we have a triangle. Well, let's switch over to the rectangle. So the perimeter of a rectangle, we don't have 4 sides the same. We have the width and the length. The perimeter of a rectangle is 2 times the length plus 2 times the width. Okay, and the area is length times width. Okay, triangle, the perimeter of a triangle, so we have a triangle with sides A, B, and C, and it has a height of h. So the perimeter is going to be side A plus side B plus side C. And the area is 1/2 B, which is the base, times H, the height. Okay, and then the last step, we have our circle, right? So the circle has a radius of R. So the circumference is going to be 2 times pi times the radius. And the area is pi r squared. So that's just a kind of a quick review for you of perimeter, circumference, and area. And we're just going to do some practice problems with that. So example 1 says, find the perimeter and area of the rectangle. It's kind of got cut off a little bit here, but our rectangle is 8 meters by 13 meters. So I know that the perimeter is 2 times the length plus 2 times the width. So it's going to be 2 times 13 plus 2 times 8. And if you calculate that, I get 42 meters. Because our original measurement is in meters. The area is just length times width. So the area is going to be 8 meters times 13 meters, which gives us a result of 104 meters squared. Okay, so that's how we do the rectangle. The next 3 examples, the square, the triangle, and the circle, you can try on your own, and I will do on the call on Friday. And then the last thing I wanted to show you is one of the 2 examples on the back of your notes. So let me switch over to that. So I think those are all pretty straightforward. Again, I'll do these on Friday, but I think you should be able to do those. We're going to do example number 3, and then I'll do example number 4 on Friday as well if anyone needs to see that. So kind of steps it up a notch. Instead of giving you the measurements for the triangle, they give you the triangle on a coordinate plane and ask you to find the area and the perimeter. Okay, so if you remember, the area for a triangle is 1/2 base times height. Okay, and the perimeter is sides A plus side B plus side C. So we have some things to figure out. Actually, in this case, finding the area of the triangle is actually going to be easier than finding the perimeter of the triangle. So the first thing we need to do to find the area of the triangle is find the height and the base, the measurements for those. So that's the height and that's the base. Okay, so if we look at the base here, that's our x coordinate. So it looks like it goes from 1 to 7. That means that the length of our base is 6 from here to here, right? Looks like that's 6. And the height, it looks like we can also calculate. So our height goes from 2 to 8. So if I count that, 1, 2, 3, 4, 5, 6. The height is also 6. So to calculate the area, I'm going to do 1/2 base, which is 6, times height, which is 6. And if I calculate that, I get the area is 18 units. We don't know what we're measured in. The little bit trickier part is going to be find the perimeter. So we found, to find the perimeter, we need to find the lengths of all 3 sides, right, and add them together. Well, we found the perimeter, or we found the length of the red side, right, B. But we also need to find the length of our green side and our blue side so that we can add those together. And how are we going to do that? We can't, they're not nice and square like our other sides. So what we're going to have to use is we're going to have to use our distance formula. So if I want to find the distance between P and Q, Remember that the distance formula is the square root of x2 minus x1 squared plus square root of y2 minus y1 squared. Okay, so that's where we're going to have our points. And remember, I like to label them all. So I remember what I'm doing. So I'm going to call Q x2, x or y2, and P x1, y1. Okay, so 4 minus 1 squared plus 8 minus 2 squared. Okay, and then if you do some calculations, I get that PQ equals about 6.71. All right. Then I also have to find the length of my blue side, which is Q, what is that? QR, right? Yes, QR over here. This is R, it's hard to see. Okay, so QR, we're going to use the same distance formula. So I've got 7 minus 4, that's my change in my x's, squared, plus, sorry for the messy writing, 2 minus 8 squared. And if I calculate that, I get that QR is about 6.71. So it looks like QR and PQ are the same length, which now looking at the diagram makes sense, right? So now I want to find the perimeter. What I need to do is add up all the sides. So I have that PR is 6, and PQ is 6.71, and QR is 6.71. So if I want to know what the perimeter is, perimeter, it's going to be 6 plus 6.71 plus 6.71, which I calculate to be about 19.42. Okay, so that's how you do example number 3. We will try example number 4 on the call, but now you should be able to at least get to most of your homework. We'll still have class on Friday, and bring any questions that you might have. Hope you have a great rest of the day. Bye.